Here we're going to draw a triangle accurately. ABC, where AB is 10, BC is 6, and the angle CAB is 30. I'm going to start by drawing that length AB. I'm going to do that by pulling out a ruler. So I'm going to get my ruler. I'm going to tilt it slightly, and you'll see why in a second. If I move it a bit like that, we can draw our length of 10 centimeters going from here down. That will be 1 point at the end, and then all the way up to 10, which is there. Okay, that's going to be my first length, and I'm going to call this point A and this point B. Now I'm going to put in the angle CAB, so that's the angle here is going to be 30 degrees. I'm going to get my protractor, and I will twist it round, put it on the line here, and I'm going to measure an angle of 30 degrees. So 30 degrees is going to come off here. Oh, let me just try and draw a little bit of a cross there. There you go. Which means I'm now going to have to draw a line through there in a second. But I don't know how long that line is, because I don't know how long the line is from A to C. All I know is that it goes through that point. So that was pretty much perfect. I'll draw through here a line. I don't know how long it's going to be. Can I get onto the ruler to draw here? Here we go. No, it's not letting me draw. Oh, what's going on here? That one's working. Let's try again to draw on here. No, okay. Let's try something else. Let's get rid of the ruler and just try drawing a straight line, shall we? See if that works instead. Ah, there we go. A straight line through there. Perfect. Okay. Now the other thing we know is that the length from B to C is 6 centimeters. Now I could do that using a ruler. What I'm going to do though to do that is I'm going to set my compass to 6 centimeters instead. Because what I want to do is I want to draw all the points that will meet across. So I want this to be set to 6 centimeters. Here we go. There's 6 centimeters. Can I get it precisely? Perfect. Twist it round. Place my point on B. And then if I draw from here, I can now get rid of my compass. So I know from there are 2 places where that length will be 6 centimeters, either from B down to that point there, or from B down to that point there. So there are 2 possible values of C that would make this, that would satisfy this particular scenario where AB is 10 centimeters. We know that's 10. Ooh, go back to pencil. We know that that is 10 centimeters. We know that this length here is 6 centimeters, or this length here is 6 centimeters down to C. And we know that this angle here is 30 degrees. So there are 2 possible triangles that we can get out of this. Now, if we want to find the angle ACB, that means there are 2 possible angles that we could find. We could either be finding this angle here, or we could be finding this angle here. And this is what's known as the ambiguous case of the sine rule, because in this case we are applying the sine rule. We have 2 pairs of opposites. We have the 30 opposite the 6 and the 10 opposite the angle that we want, or indeed opposite that one. So in both cases it's a sine rule, but there are 2 possibilities going on here. If we think about what this is in terms of the calculation, we would have, we're trying to find an angle, so sine of 30 degrees over 6 is equal to sine of C over 10, which means that sine of C is equal to 10 sine 30 over 6, and that gives us that C is equal to 56.4 degrees. We can clearly see that if angle C is 56.4, then that can't be this one. It must be this one. This angle here has to be 56.4 degrees. And the sine rule will only ever give you that one by default. We need to work out the other one using this diagram. But fortunately, we know that these two lengths are both 6, which means this is an isosceles triangle, which means this angle here is also 56.4 degrees. And so the second angle is going to be 180 minus 56.4. So sometimes we label this as C1. So if I put C1 in here, and this as C2. So C2 is equal to 180 minus 56.4 degrees, which is equal to 123.6 degrees. So the ambiguous case of the sine rule says that there are potentially two different scenarios, two different angles we could get when we have this situation. Now, what would happen in each of these scenarios when BC is equal to 5, 3, or 12? Well, let's have a think. What's going to happen? Let's pull up our compass again. If I set it to 5 centimeters this time, instead of being set to 6, I place it on here. Let me rotate it around a bit first so we can see it. And this time as I draw it, let's go for a different color, let's go for green. We see that it just touches it at only one point. There's only going to be one solution this time, not multiple solutions. This time when I draw that line from B down, it's going to come down vertically and hit that. And we're going to get a right angle triangle, and there's only one solution. What about when it's equal to 3? So let's do something similar. We will grab our compass, we will set it to 3 centimeters this time, and try and draw around. And this time we see as we move it around, it never touches. It's never going to touch that bottom line, which means there's no possible solutions. There's no way this can work. And what about when we set it to 12 centimeters? When we set it to 12 centimeters, I wonder if this will go big enough to go to 12 centimeters, or not quite big enough to go to 12 centimeters. That should be big enough to see what's going on. When we do it to 12 centimeters, we're going to get, let's get rid of that because we can't really see it, can we? When we do 12 centimeters, what you're going to end up with is you're going to end up with one really long line going over here, which will eventually touch. But the other one's actually going to come over here, and you're going to end up with a second triangle, but it's not going to be quite the same because it's not the 30. It's actually going to be 150 degrees at angle A. So that one doesn't quite work. So the only case where this led to something where we got this ambiguous case where it was equal to 6 here. So there are only certain scenarios where this happens. Not every time will you get two possible things. And it's actually a very specific case. This only happens when we are given two sides and a non-included angle. And even then, it has to be specifically to do with the size of that sort of side opposite the angle and how long it is as to whether it will lead to something that is ambiguous or not.